Okay, so the last part of this section gets into finding the sample size required to estimate a population mean mu. So like in the last section, in order to determine how many sample items we need to estimate and population mean, we can rework the margin of error formula to develop a formula for finding minimum sample sizes, given the confidence level, sample mean, and margin of error. So the sample must be a simple random sample. So again, we're kind of assuming that for all of these, but technically we should be looking to make sure that that is occurring. So we have our z-score for our, based off of our confidence level. We have our given population standard deviation, and then we're going to need to know what the margin of error is up front. So, and then make sure we square it. Now then, of course, the rounding is the same as before. This is a sample size, so we cannot have decimals. So again, no decimals. So no decimals for this. All right, so let's see what we got. Use the given data to find the minimum sample size required to estimate an unknown population mean. Credit rating, how many adults must be randomly selected to estimate the mean FICO credit rating score of working adults in the United States. We want 95% confidence that the sample mean is within 3 points of the population mean and the population standard deviation is 68. So we have our 95% confidence. Now, because we're talking about means and standard deviations in here, that forces us to have to use this formula. We know we got to use 7.2 formulas. And then the population standard deviation is 68. So again, this is our sigma. Sigma equals 68. So the only thing we don't really know, they tell us this other little bit of information, that the sample mean is within 3 points of the population mean. What the heck does that mean? Well, anytime you see this word within, that is your clue that they're talking about the error. So within 3 points means E is 3 points, or so the error is 3 points in this case. So now we have those two pieces nailed. So we just got to get our z-score. So remember, this is going to be a special one. So z sub alpha over 2 is 1.96. Now you're good to go. It's plug and chug. So you got n is equal to 1.96 times our 68 divided by 3, and don't forget to square it. So we got 1.96 times 68 divided by 3 equals that, and then we want to square it. So we get 1973.728. So this is going to be 1974. And what are our units? We're talking about people here, specifically adults. That should be our answer. 1,974 adults. Okay, the last one, a lot of reading. But again, you got to tease out the useful information. So you want to estimate the mean weight loss of people 1 year after using the Atkins weight loss program. Okay, that's garbage. There's nothing there. How many people on that program must be surveyed? How many people on that program must be surveyed? They want to know what N is. Based on that statement alone, they want to know what N is. If we want to be 90% confident that the sample mean weight loss is within 0.25 pounds of the true population mean, assume that the population standard deviation is known to be 10.6 pounds based on data from blah, 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 blah. Is the resulting sample size practical? Okay, so they always have, sometimes they'll throw that little analysis at the end, but that's minor compared to the math. So let's see what we got. So 90% confident. So we know that that is going to be a special z-score again. So z sub alpha over 2, 90%. Anybody remember? 1.645 should be that z-score. So that's that. Z sub alpha over 2 is 1.645 within 0.25 pounds. So that's our error. So E is equal to 0.25 pounds. And then, I think my lead's about dead. Get some more lead going. And then, what else do we know? Standard deviation is known to be, population one, is known to be 10.6 pounds. So we got sigma is 10.6 pounds. So we're good to go again. So we're plugging everything in. We got 1.645 times 10.6 all over 0.25. And don't forget to square it. That's the most common mistake, is people forget to square it. Don't forget to square it. So let's see what we get. 1.645 times 1.645 times 10.6 divided by 0.25 equals squared 4,864.78. And of course we got to round this up no matter what. Even if this was a 0.28, we would have to round it up because that's just the way it is. We want to have the minimum, so we want to have more than enough. So 4,865, and it doesn't really say adults or anything, it just says people, so we'll just say people. Now, is the resulting sample size practical? Well, that's kind of a subjective question, because where are we talking about? You know, are we talking about in the whole United States? Are we talking about in New York? Are we talking about in Malone, New York, or Saranac Lake, or who knows? It really depends on where you're looking. So I would say depends on location. You know, so that's not really a great answer, but it really does depend on the location. More than likely, are you going to find almost 5,000 people in the vicinity that are on the Atkins diet? So, but likely not practical because there likely isn't enough on the Atkins diet. So that would be my interpretation of it. But again, you kind of see where I'm going with this, hopefully. You know, it really depends on the location, but more than likely you're not going to find 5,000 people in a close bubble that are all on the Atkins diet, unless you're in a big city or something. So, all right, hopefully that clarifies things for you, and that wraps up this section. So, we'll see you in the virtual classroom. Have a good one.